Okay, everyone, this is going over problem number 1 of the Practice Machine Design and Materials exam that can be found on engineeringappliedpractice.com. So this question is a very basic question. It goes over some fundamental topics that are on the exam. So we're talking about unit conversion, we're talking about material properties. So I'm going to jump right in this problem and work it out for you. The problem asks, calculate the weight of the steel part shown in newtons. Assume the drawing to be third angle projection. Dimensions are given in inches. So one trick that we're going to have to look out for at the end is to convert the problem from imperial to metric. Of course, we're going to have to use the density of steel to try to come up with a weight or a mass of this object. So the strategy for this will be to use a few different formulas, one of which is to calculate the total volume. So the total volume is going to be equal to the volume 1 minus the volume 2. Volume 1 will simply be equal to the cross-sectional area, so that will be 6 inches times 6 inches, and then times the depth, which is 5 inches. And so that will be the first thing that we need to get done on this problem. The second thing that we need to get done on this problem is to calculate the smaller volume. So that will be V2 is equal to 2 inches times 2 inches times 5 inches. So maybe we'll be a little bit lazy here. We'll say that it'll be equal to 5 times 36 minus 4, which is equal to 5 times 32. So let me get my calculator, and we'll do 5 times 32, which is 160 cubic inches. So that's the volume of this shape. And if you guys are a little shaky on what I'm doing here, I'll illustrate. So this is the front view. You have 2 inches here, 2 inches here, 6 inches, and 6 inches. And then looking from the right view, this again is third angle projection. That would be good for you to review for the exam as well. That would be looking at this shape right here. So the volume that I found, this is the total volume, which is V1, I guess this is also V1 minus V2. So hopefully that all makes sense. The next thing that we're going to have to do is try to find the weight or the mass of the object. So in this case, we're going to use the formula for density. Density is equal to is equal to mass divided by volume. So what we want in this case is the mass. So let's solve for that. We have mass is equal to density times volume. And so the density for steel is 0.286 pounds per inch cubed times 160 inches cubed. So let me punch that in the calculator. So we're going to get that the mass is equal to 45.8 pounds. I'm going to put pound mass because I want to go through a full sort of unit conversion, if that's helpful. So we can say that there's 32.2 pound mass feet per second squared per 1 pound force. The pound mass cancels out. Then we can say that the weight is equal to mass times the gravity constant. And so you're going to get so this was pound force second squared per feet. And so now we're going to take this, which is 1.42 pound force second squared per foot, multiplied by gravity, which is 32.2 feet per second squared. Units cancel out nicely, and we're back to what we originally had, which was 45.8 pound force. Imperial units are tricky sometimes. Sometimes it's nice to go through the full process. In the case of density, you can just say that the density is pound mass or pound force when it's a problem like this. Okay, so now we have this weight of the object, which is what we're looking for. However, the problem asks for newtons, not pound force. Okay, so let's convert to newtons. You can look it up. However, there's a pretty easy formula that I use for work, which is just that 1 pound force is equal to about 4.4 newtons. That's a little bit off, but good enough for this problem. So I'm going to do 45.8 times 4.4, and we get 201 newtons. So let's see, the answer is A. Okay, that's it for problem number 1. You can leave any questions in the comments section. Goodbye.